Hello everyone, and welcome back to a mathematics tutorial video. In this video I want to continue our discussion talking about distance, specifically when the x's are equal. So if you remember back to a previous video, we had equal y's. Well, this time we have equal x's. And I want to sort of go through that same framework to developing a way that we can approach these problems. And so in this case, we're going to address the question, what is the distance between the points 3, 1 and 3, 3? So I want to begin by setting up that same sort of notation here of the point 1 having an x1 and a y1, and having point 2 having an x2 and a y2. And this is going to be extremely important when we start doing distances where we don't have one of the dimensions the same. But this to build up the idea of this notation of x1, y1, x2, y2. So let's go through here and let's do our point 1 as 3, 1. So our x1 is going to be 3, so x1, and our y1 is going to be 1, right? Because the x, y, this is the point 1, this is the first point. So we're going to go ahead and let's actually put this on the graph here. So we're going to go over 3, right? Because x is 3. We're going to go up 1. So we're going to put our point right here. Right, this right here is the point 3, 1. So then we have our second point here, which is the point 3, 3. So we'll do 3, 3. So in this case, our x2 is going to be equal to 3. And our y2 is going to be equal to 3. Let's go ahead and plot this out. So same x, go 3 along the x-axis. Then we're going to go 3 along the y-axis to go up to here. All right, so this right here, this is the point 3, 3. And again, just to sort of remind ourselves what we're looking for is we're looking for the distance, right? We're looking for this right here. Right, we're looking for distance, right? And again, just like what we did before, just sort of visually looking at this, it's clear that the difference is going to be going along the y-axis too. So again, in this case, just like before, our distance here is 2. But again, let's develop a framework for how we would approach this if we couldn't graph it. And let's, and maybe these numbers aren't quite as easy to wrap your head around. Let's go ahead and let's develop a framework. And let's do this in the same way we did with the x's. So we can say that, if our x2 is equal to our x1, right? Then, right, so if our x's are equal, right, that means that as we move from one point to the other, we are not making any change in the x direction, right? Then distance, right, then our distance here is going to be equal to the absolute value of x2 minus, the absolute value of y2 minus y1. All right? And that makes perfect sense, right? If our x's are the same, then to get from this point to this point, all we have to do is move along the y in the y direction, in this case 2. And that's the difference between y2 and y1. So let's really quickly go ahead and use our example right? So in this case, right, D is equal to, right, the absolute value in there, because I think that's important, and then the absolute value of y2, which in this case is 3, minus our y1, which in this case is 1. So in this case, then, we get a D being equal to 3 minus 1 is 2. Or D equals 2. So hopefully this makes sense. Again, there's a lot of similarities between this and the equal x equal y's video that we watched when the y's were equal and when the x's are equal. So hopefully this made sense. If it didn't, I encourage you to pause the video, go back, rewatch any parts that don't make sense, and as always, please reach out. Thank you.